I wanted to do a couple of examples of applications for you, and these are pretty standard applications that people learn when they first learn these trig functions. And it's just a demonstration of how to use it. And these are problems where you end up with getting right triangles. So you can use your trig functions to figure out whatever is unknown. So it says a tree is being cut down and makes a 70-degree angle with the ground when the tip of the tree is directly above a spot that's 40 feet from the base of the tree. Find the height of the tree. So the first thing is to draw a diagram. You don't have to make it look like a tree. You can just make it look like a line, but you can do a tree if you want. So it's being chopped down, and at the present, it makes a 70-degree angle with the ground. So 90 degrees would be straight up. So this is kind of tipping over a bit. For some reason, it hasn't fallen. Maybe it's leaning against another tree or something. But anyway, it makes a 70-degree angle with the ground when the tip of the tree is directly above a spot that is 40 feet from the base of the tree. So I label on the diagram all of the numbers that I'm given. So the 40 feet goes there, and I put that little apostrophe on it there. It stands for feet, of course. And I know the 70 degrees told me that, so I labeled that 70 degrees. And it didn't tell me anything else. So I must be able to find the height. I need to find the height. So I'll label where the height of the tree, not how far it is from the ground to the tip of the tree, but the height of the actual original tree, which is h. Okay. Okay, so I have the adjacent side, the hypotenuse for my formula. I'll need the adjacent side, the hypotenuse, and the angle 70 degrees, which I'm probably going to do a trig function of. So since it's adjacent and hypotenuse, I could use cosine, which would be adjacent over hypotenuse, or I could use the reciprocal of that, cosine, which would be secant, right? Secant, which would be hypotenuse over adjacent. It doesn't really matter. Usually I would just use cosine, because cosine, sine, and tangent are the ones that we use most often, so we're comfortable with them. So you can, this is pretty easy to solve. It's just a proportion, so you can cross multiply. Put the h on the left, the cosine 70 goes on the bottom of the 40, right? Now, cosine 70 degrees, that's not one of our nice triangles. If it was, maybe I would have to give an exact answer. But this one probably should have told me how many decimal places to give, because it is an application problem, so you are estimating the height of the tree. Of course, it's not going to be exactly 70 degrees, and it's not going to be exactly 40 feet. There's a measurement error, right? So it's reasonable to round it off. So I just cross multiplied, the h goes over here, and the cosine 70 goes down there. Just cross multiply. And I get this. H is 40 over cosine 70 degrees. I put my mode of my calculator into degrees, and then I just enter that, and I get approximately 117 feet. I figured that since the base was given in feet, and it wasn't like 40.1 feet or 40 feet 1 inch or anything like that, that is probably only accurate to feet. So I just rounded it off to feet. So 117 feet is how tall the tree was originally, right before I started chopping at it. So again, make sure the mode is set to degrees. This is like the thing you should be most paranoid about when doing these kind of trig problems is your mode in the right? Do you have it in the right mode? The wrong mode gives 63.2 feet, which is completely wrong. So you don't want to do that.